Great. Hi, everyone. Hope you're doing well today. Today we have a super special session for all you coders because I know that this is what people usually think of game development as. So today's our first session in Unity. It's going to be given by Kotob. Kotob, as you'd like to introduce yourself, go for it. This is going to be the first of 5 or 6 Unity sessions. So we have quite a distance to go. And hopefully by the end of it all the knowledge that you've gained from the sessions you'll be able to use and to build your first platformer, or second if you've already built your first. Kotob, it's all yours. Take it away.
Hey guys, so I've been working in development since 2017 or so it's been like 5-6 years. I've done a lot of mobile games and other types of games, web games, and some PC games and other weird stuff across a few countries. I've been in Turkey and Germany, and I've worked with companies from all over. Currently I'm back in Lebanon, working remotely. It's nice. And yeah, so I'm excited to give this Unity session. And gonna do that in a bit.
By the way, Kotob, question. Usually, this kind of works like a Twitch chat to a certain extent. So
Okay.
some people may have questions in the chat, or they may raise their hands and you'll have to unmute them. Okay? So just 2 or 3 things to keep in mind. وإذا في شيء يعني we'll unmute and tell you.
Sure. I'll keep the I'll go back to the chat every now and then.
Okay.
I guess I can go ahead.
Yes, let's do it.
Okay, I'm gonna share my screen. Desktop 1. Okay. I hope I don't have to restart. Nope. Oops. Okay, I have to restart.
No worries. Oof. Okay, so Zashi, until Kotob comes back, just to give you like a very quick overview on the Unity engine. So generally people that use Unity really like to make games مثل Hollow Knight, مثل Mario to a certain extent. But also a fun fact is those of you that play League of Legends, is that you've seen the mobile version of League of Legends. This was also made in Unity. So you have all kinds of games that can be made Palishia, which is really cool. Oh yes, you need to be co-hosted. That's true. Make co-host. Yes, Wild Rift is in Unity. Cool. كتب مش الحال.
Can I share screen? Yes. So share. Here we go. And yeah, so I'm gonna quickly just show the plan, just an outline. This is what we're doing today. Creating a Unity project, details about that, covering the basic user interface, going over the different game object and components, not all of them, just the main ones. Platform and movement design, what we want to be doing. And yeah, like some scripting instruction in the abstract, like the life cycle of the game objects. And doing the coding for the player controller, part 1. Just gonna do some basic coding. And that's gonna be about it. It's gonna be like around a 1-hour long session. And yeah, we can get started. I'm gonna stop video. Can go ahead, gonna create a new project. So this is the Unity hub. I'm not gonna go into much detail. Essentially, you install the Unity version you need, and then you just create the project. There's LTS versions, which are long-term support. They're more stable, so we'll just go with that. I believe this is entirely in 2D, if I'm not mistaken. Am I mistaken? Ashraf, I believe it's entirely in 2D. Okay, I'll just go with that. Thank you for the confirmation. Okay. So you can also use templates. So that's what we did. We used the 2D templates, and you can also pick from different rendering pipelines. Mostly the older one called standard or built-in, or URP, which is the universal rendering pipeline, which is newer. Also can be separated into HDRP and LWRP, which are older. Now it's just mainly just pick between URP and built-in based on the other plugins you want to use. So currently you shouldn't really be worrying much about that right now. Project being created.
Kotob, we can't hear you.
Yeah, sorry. So this is the project that's been created. Let's see what we do now. I'm just going to cover the essential windows. Okay, let's see. So essentially, it's split into different parts by default. There's some that are hidden, so you just can open up these hidden windows later as you need. There's the project view, which is the file system. It has the all the files that are in the project that you can add. You can create your own folders. These are the ones that are built into packages. You have the hierarchy, which is in the kind of scene tree essentially of what's currently exists in the scene. By default, you just have a camera. You can add other things. You can have like add a light, an audio, a video, UI, and so on. You have the scene view, which is where you edit things and move them around and so on. So to create like an empty 2D triangle, it's gonna just drop here and you can move it, expand it, and so on. So this is the view. The game view is you actually play the game and see the final resolution. So you can change this to different resolutions depending on what you want to be, what kind of device you're targeting. In the inspector, you see more information about the object that you have selected and the components that are attached. If you press on the main camera, we have the camera component attached and the transform is attached by default to almost everything. And you can change the properties there for the components and so on. The console is where you see error messages and other things while the game is running, essentially, or from the editor if there's like an issue or so on. It's useful for information, for logging, for kind of like keeping track of what's happening for yourself. And these are the views that are open by default. This is kind of the main things. There's also the, I think that's it for now. You have a few more useful things potentially, like for example, the lighting explorer, which you'd need for, fancy lighting changes. You have the recorder that you'd have if you have it enabled and so on. And so on. The animation one is also very common to have it open. You can add the animations and the keyframes for those that you have open. So yeah, and you have you can switch between in the scene view, you can switch between what gizmos you do to modify things. And that's mainly it. You here have some like icons for different ways to toggle settings within the scene view to make things easier and to visualize them or not. And yes.
I don't mean to interrupt you, but people are asking if you can slow down a little bit, the way you talk. Sorry.
Sorry. Yeah, okay. I will slow down when it gets to the other parts. For now, this is a bit of surface level. So let me know if you have questions. I'm gonna check the chat, the Zoom. Let's see. How do I check it from here? So does anyone have questions about any of the views or anything, or is it just from now on, slow down? Let's see. Okay, so I don't think anyone has any questions about these things I just covered. Slow down, moving on, for sure. For the game objects and components, so yeah, so this is where things get more into the actual architecture of the engine. I know how it works. Essentially, everything is made up of components attached to objects. So by default, almost everything has a transform component attached, which includes information about the object in space, like its position, its rotation, and its scale. And for UI components, it has a different type of transform component, but essentially everything has a transform component for it to exist in the game space. And then other components exist that help you, that add physics, like such as colliders. So you have where objects end and where the other objects start, and kind of like things such as rigid bodies or so on components. So that, let's see what questions there are. What is Z into D? It's actually depth. So like kind of like layers, like if you just put multiple stickers on top of each other, essentially, the ones with the higher Z are the ones closer to you, essentially. Like just if think of it as like stickers on the back of a laptop. Yeah. Or background, definitely. It could be background, it could be like the background foreground, or just multiple, like the kind of like the background and then the landscape and so on. So yeah, so physics, objects could be colliders or rigid bodies. Rigid bodies give it like the kind of velocity, movement, and kind of other gameplay behavior. Same as order and layer. Not exactly. So there's kind of, yeah, weird interactions like that in Unity between order and layer and Z. One of them would take precedence over the other in a specific, usually. Order and layer takes precedence. The layer is like, they can have multiple Z's within the same layer or vice versa. It's, yeah, some things are weird. You just have to, you know, get used to them. Yeah, visualization components such as the sprite renderer, which you know, make things visible in a scene. Like something could have a physics actually and have a collider that actually could be like bouncing around in the scene, but you can't actually see it because you don't attach anything that makes it render. So for 2D, that's a sprite renderer. For 3D, it could be anything like cubes by default, or you know, models you import from outside. You have lighting. You have directional point lights, spotlights. They're just different types of light, you know, like a sun or like a lamp or like a torch or so on. Audio sources that add music or sound effects, video players, and UI, which there's kind of some built-in helper objects, such as, you know, for text, for buttons, for sliders, for so on, and others you can add as packages or, you know, create your own by combining with these. Cameras, obviously. And yeah, let's see what other things are there. Some things that are more like more like game specific, like time maps, because not every game needs a time map. And definitely not every game needs a hexagonal or isometric tile map. That's kind of like very niche, actually, to have like a game with hexagonal or isometric tiles, you know, like a board game, essentially. Sprite shapes, perfect cameras for, you know, pixel art and so on. So yeah, those are the main components, I would say. You would be surprised how far you could go from there. Most of the work you're doing is with these components and also with the components you create yourself. There are also some things like navigation or, you know, things moving around using AI. Let's see. Particle systems to kind of like makes the nice, flashy, juicy things like explosions. And yeah, and also, but essentially, most of the time, you're actually writing scripts, attaching scripts who are components that you create. So essentially, every new code file that you create is a new type of component, actually, that you attach to an object. So for example, let's create here, some call this, I don't know, player. But someone ask a different question? No. So this now, let's see where this was added. Okay, so now we have a new script called the player. And yeah, it's kind of extends. So okay, before we get into that, let's see if we covered everything we want to cover. Yeah, so that's the game objects and components. What are they and how to create them? That's the surface of it. Platform movement design, what we are working towards and what are the requirements. We're just kind of trying to make a simple game where there's a player that moves, it moves, it jumps, and it shoots. A camera follows it. It has a cute animation as it jumps and does things, and the tile map system to create the level, the kind of the cubes, the all cubes and things that add up to create the level you're playing in. We're gonna have an basic UI creation introduction. So creating a main menu, the buttons you have there, and the title text. I'm sorry, seems like someone is asking. Oh. It's just extensions. Okay. Sub comments. Main menu. Scene management, how to switch between scenes, because the main menu is usually a different scene. So scenes are essentially, so currently there's only one scene now, the sample scene, but you can have multiple. Like one for the main menu, one for the game, or different UI. Like different parts of the UI could be different scenes, different game levels could be different scenes. It's up to you really how to use them. You can have everything in one gigantic scene, even if you wish. So scene management, how to switch between scenes, implementing player health as UI, and so on. Connecting the UI to the player, essentially, singletons versus event, kind of two different ways of doing things, and when to use either. The answer is depends. Scriptable objects, which are essentially kind of like, scriptable objects. They're like kind of scripts that you create that kind of turn to data files, essentially. So another way of saying scriptable objects is saying something more like data files. Scenes as in layers, well, they can function as layers because you can spawn scenes additively. You can put like multiple scenes on top of each other. So you can have like a scene for the UI and a scene for the UI in a game and a scene for the gameplay itself, and just add and kind of have them spawn on top of each other if you so choose. By scenes, usually you mean a self-contained scene in the game. How should I choose to create a new scene or show hide objects in the same scene? Well, generally you want to use one scene. I recommend using one scene most of the time, unless you know what you're doing very well. I mean, kind of like having an understanding of the components and how they interact. Generally, things on a separate scenes are things that don't necessarily interact much with the current scene. Like, for example, the separation between gameplay and UI. Or different scenes that, like if you have a big level in 3D and you want to separate it into chunks, for example, or things that are unrelated. Yes, so coming from Unreal or something, they function as worlds, essentially. A scene is like a world, pretty much, yeah, like a room. A box of things in it, essentially. Like a level, pretty much, yes. Like a level in a game. So you would create multiple scenes for different levels in a game. Like every like if you're creating, for example, Angry Birds. If you're creating Angry Birds, then one moment. Creating Angry Birds, then you'd have the title screen maybe as one scene, then the main menu as one scene with some transitions between the same scene, so it looks nice. And then every time you press on a different level, yes, scenes are chunks of the game that are put together. Not necessarily, usually no. You can do that, but they're actually the current part of the game that you're playing at the moment. One question at a time. Objects that interact with each other are within the same scene. Yes, so like just to make things clear, generally you want to have a main menu and then the game. So when you switch between scenes, the game does get stuck a bit. So over time, you would switch to having things within the same scene and turned on and off, depending on how much you care about loading time versus like initial loading time versus later loading time. But again, guys, I don't want to confuse you. Generally, you would have the basic cases is your main menu, and then, for example, if you're doing Skyrim, like one gigantic scene called Skyrim. Obviously, that's not how they do that because they have to load things on and off on the fly. But for our purposes, yes, if you're playing Angry Birds, every Angry Birds level is a different scene that they connect from scene to scene or by going back to the main menu, which is a separate scene. I hope that clarifies things. Are there any other questions? Okay. Data files, basic anime AI, so machine states, which are just enums, if you're familiar, mostly, and kind of like jumping between different like loops of enemies doing things, states of action. And polish, where we create particle systems that makes things look fun and interesting. Important modules to add, I guess, do tween probably, and some audio components. Screen shake, because, you know, the thing, Rami, and hit stop and tweening into the shaders. Yeah, it's nice to go over this, what they are in concept, in theory, and how we use them, but definitely not going to go potentially into any one of them, except maybe to just cursory explain how it works. Maybe as a visual shader actually would be nice, different nodes of it. So that covers the platform movement design. What we're working towards and what are the requirements. We're trying to create a simple 2D game where the player jumps, shoots enemies. There's a level in 2D, a camera, a UI, and enemies, and it's a bit polished and with music. That's in summary. What are the requirements? That's our scripting introduction. The Unity loop consists of, so essentially these are the main lifetime methods, they are called. The start, update, fixed update, on enable, and on disable. So somewhat self-explanatory. The start runs when like when an object is, when the game starts, essentially, when the scene is loaded. So this is where you put things such as creating, like if you have a game manager that's and you're like spawning things like like when the game starts, you load I don't know, things from the internet as soon, or something like that. You would put it in the start method, or like sending analytics, something like the game has started, you know. Update is the function that runs on every frame. So the concept of frames in games, you know, frame data, frames per second. It's basically the computer telling the screen what to show every interval of time. Yeah, so basically, if you would do things here that such as like following the handling input actually, and following the mouse, and movement. Actually, we're going to do that here. But for physics movement, you might look at fixed update, which is independent of the frame rate of the screen, which you should definitely things related to. So generally, the best course of action is to gather input in update, and then pass it on to fixed update, so you can actually perform the movement changes in a smooth, consistent way based on deltas or whatever. On enable and on disable, so these are slightly different. They might run more than once per object. I mean, this start runs once, update, fix, update run constantly. On enable and on disable run, you know, when an object is enabled or disabled. Self-explanatory. These are similar to destructors and constructors in C++, if anyone cares. Obviously, you know, when you want to remove things or add things to the scene to clean things up. And by default, when you create an object, okay. Yes. By default, when you create a component, it gives you two lifetime methods by default, the start and update, which are the most common. On enable and on disable are rarely added. I rarely use them personally, because start works better than on enable for most cases. And yeah, on enable and on disable actually mostly useful for turning on and off subscriptions to events. So that an object that is actually technically off, hidden, is no longer receiving events that is subscribed to at some other point, we'll get to events. Yeah, pretty self-explanatory. And that gives us, can you use the on-enable, disable for special features in the game? Yes, you can use them for whatever you want to happen when an object is enabled or disabled. Generally, event subscriptions. How can I determine which event is enabled now when I have multi-events? That is not clear to me what you mean. Generally, you can like an object can be subscribed to multiple events at the same time. There's no like rule that says you can only be subscribed to one event. You can be subscribed to multiple events. Every event subscribes to a function. So you feed an event into a function that gets called when the event is called, essentially. It's not just an event to objects, actually event to function, event to, there's other names for that. Closures, you can call it whatever you want. Functions, methods, function, so on. Yeah. You're welcome. Now we can get to the actual programming part. I guess we have 20 minutes. Then I can leave a couple of minutes for questions. Adding physics using rigid body, adding collisions, reading inputs, considering using the input system. Maybe not this time, maybe I'll update for the next time. We'll go over it at the beginning. Installing the new inputs package, moving the player left and right, and so on. We'll see. I'd rather have more time for questions this time. And then, you know, do a bit more meaty stuff later. Because this is actually a bit of like high-level conceptual stuff around the engine architecture. Cool. Let's see if I remember what I've been doing for years. What about collision in 2D? It was like a paper. Yes, collision in 2D is made of usually like flat shapes, geometric shapes, like squares or triangles or spheres or polygons, which are just dots connected to other. So instead of having like a cube in space, you'd have like a square. And let's see. Yeah, so I'm gonna attach this one here. give it a box collider 2D, give it a rigid body 2D. So what we added here is we gave it essentially physics components, one of which is the collider that handles its bounds. So we know where the box ends in the physics space. Generally, because this is a square, it automatically clipped to it, but obviously you can actually change it. For things like the player, if you want it to be a bit easier for the, you generally would make the collider a bit smaller. That's one example, one and a half example, so that it's less likely to die, things like that. Rigid bodies, they can be dynamic, kinematic, or static. Static is for things such as things that are in part of the environment that you don't actually want to have them moved. Is it guaranteed to collide with each other, or it can one up and one down in depth, so it would not collide? Well, that is a good question. I believe that, if I'm not mistaken, I believe that the position in Z actually does not matter for physics, or it does. We can check. Is the collider close to the hitbox concept in enemies? Yes, it is 100% equal to the concept of hitboxes in fighter games, in 2D fighter games. Yes, so what rigid body types could be static for things that you don't want to move at all, you don't care about them, like for example the floor. Dynamic for things that are like actually just kind of like I don't know, balls in a scene. Like if you have like I don't know, like a box full of basketballs, and like just throwing basketballs into a giant box, then the box is static if you don't want it to move, and the balls are dynamic because they have physics, they're bouncing around, they're hitting each other, etc., etc. They have some properties like weight, linear drag, and so on. Can you link separate colliders to the same object? Yes. Generally, yes, you can. You can have like a box collider maybe, or so on. What I would do personally is, well, in Unity, it is not super as straightforward because generally you want the rigid body and the collider to be on the same object. So you can't have like a rigid body with children without colliders. But generally, yes, you want the colliders to be on the rigid body, and you can try to play around with having multiple colliders on the same object. You can try. Yeah, and dynamic has some interesting thing to note is the collision detection. It could be discrete or continuous. Continuous for things that is fast moving or precise, where you want the precision. Interpolation, similar. So we have like less jitter at different frame rates, and that kind of covers most things. Yes, so kinematic rigid body is slightly different because dynamic is kind of physics accurate, and static is physics no. Kinematic is a bit of a kind of game-specific concept. Every engine has different what they call kinematic, which is usually the player or things that you control through your inputs as the player, and then they work within the physics space. But instead of being physics operated, like just having like you injecting velocity into it and it hitting things and with other velocity, you so not just that, but also they are also more immune to being shoved around. Like dynamic is kind of like it's just made to be kind of pushed around and so on. Kinematic is meant to just be itself something that's moving. Like the player generally is not pushed around by environment, like grass. It's just or like when you're pushing something in a fight against it, like you just kind of when you're moving against the wall, things like that. Characters are typically set kinematic, yes, exactly. And in other engines, they are actually called character controllers in some engines. If coming from Unreal or Godot, yes, characters is what you'd call or agents or so on. Little confused. I'm sorry to hear that. Sometimes when the player has too much velocity or colliding that penetrates the box, how can I fix this? So to fix the penetrating the box collider, well, you can multiple things. Okay, so you can increase the physics frame rate count from the engine settings to make it do more calculations more often, so it's more precise. And you can also do some integration yourself by overriding some functions or so on, or by switching the kinematic to collision detection continuous. I show here, which makes it more precise also, and kind of makes it try to do the projection better for the collision calculation. Yes. So that covers essentially the kind of different types of rigid bodies and so on, and collisions. So player, so we're gonna attach now. I see we have, let's say 10 minutes. I'd rather have 5 minutes left for questions. Also, I have to go. I'm already late. And let's see. Okay, so we're gonna add now a script. So actually what I'm gonna do now is see what we can do in physics without even attaching a script. So we're gonna make the player dynamic, and we're gonna add the floor and show you how, when you run the game, it falls and bounces. That was collider. Oops, oh, never mind. Rigid body. Static. And now, by doing this, actually, let's just temporarily, yeah, that's fine. Just gonna rotate it a bit so we kind of see the happens. See, it fell and so on. You can move it and move it up again in the scene view. You can see how it falls. So yeah, now things are happening. You don't have much control, but when the game runs, it falls and it hits it. So moving on from there, let's just reset the rotation for this. We'll just add basic input movement. See, we'll give this back to kinematic, put this back on the floor, and so on. So better to create folders to put things in. Okay. We'll click this. So here in the update is the GitHub Copilot function. Amazing. GitHub Copilot helps. It's nice. Reading inputs, moving the player left and right. So I'm actually gonna do something very basic. I'm not even gonna pretend that this is difficult. I'm just gonna say read left and right arrows and move kinematic components. Let's see. Is this functional now? Or does it not want to be functional? Would you like to disable GitHub Copilot? Fine. If input dot mouse, get mouse button down, key code dot a. Wow, this is working. Blah 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 mouse. Oh, this is not sorry. Get key down. Yep. No, you would do get components. Essentially, you just generally would want to get components at the beginning. So you could do something like rigid body. Rigid body. And it's not going to do that because it's reserved. Cool. And you call it. It's just the method without the calling. Let's see. For someone who's never touched, I'm finding this one accessible. I could rewatch the point, but this certainly does not feel like a starting point. And I'm sorry to hear that. If you have comments on how to explain things better, let me know. I tried to be as, methodical and systemic as possible. Let's see. Velocity, for example, equal to, for example, time dot fixed delta, or sorry, delta time, for example, times some velocity that you create. So we're just going to create another public, or just, CRS field. Gonna call this private float air speed. Call it, make it 10 by default. I think that's fine. I think it's 100 F maybe, and it doesn't matter. In this pixel space times player speed. So this makes it go to the left velocity. Oh, so we want this to be times vector, for example, 2 dot right. Yeah, and for the, so this is for A. Left. Minus to, so it's for left into minus for the plus. And yeah, so this actually, if the speed is correct, then this should work. Now things move left and right. Oops. You can even do left and right here, just to make things easier. Generally, if there's errors in the console, that means you messed up the script, and you have to fix it. And now let's see. Oops, it's moving. It's not correct, but it's moving. So here, actually, something like this would be better for this controller. Plus minus. Let's see. Equal to minus, you just got equal to plus. Well, it seems it doesn't want to. Let's see, left, right, player speed, etc. Let me just make the speed bigger to see what happens. All right, and change signs. What? Sure. That's not my question here. Why is it not? I think that's. Lol. I don't even use the signs. We're multiplying by left and right. Yeah, see? So it moves left. Now let's make it much faster. Let's make it like 1,000. Now you can see it moving left, right, and so on. Yes, the code will be shared later. It's in a GitHub repository. This will be added to the there. Yeah, see, this is happening when you turn off the scene. The values you changed got reset, so you have to set them back, or just generally set them before the level starts. Also, one other thing you could do is that when you basically reset the so get key down, you can do else, for example, and otherwise you just reset the velocity to 0, so you don't have the drifting essentially. So I believe you basically do get key down is when it starts to press down. So what you want is actually something else. Pretty much. So as long as this key is pressed, it's setting the velocity when you let go. So whoop. So this works. Because you're actually setting the velocity here directly, instead of adding it or subtracting it, you don't actually need to multiply by delta time, weirdly enough. But it's generally what you want to do because you want to kind of smooth into the speed increasing until it hits a limit or so on, and when it stops. Cool. Back to 100. And that covers the basic how things work actually. Oops. Yeah, there we go.
All right.
There's a high speed. Let me know if you guys have any questions. We're gonna have 7 minutes left for questions.
Kotob, I know you're a bit busy, so you'd like I can take over, and this way you can bounce.
For sure. No, I mean, I'd rather hear, you know, how does everyone's thoughts, any final questions relating to what just happened. And if not, then yeah, guys, we can continue next time. I'm looking forward to doing more of this.
Most likely, I'm gonna give them like a quick overview on what a game object is, what the hierarchy is, what the project is. لأنه we went over them هيك very quickly, so they don't have any questions.
That makes sense. That makes sense.
Mhm.
Game objects, sockets, and so on. Yeah. So yeah, I guess I'll leave it to you. Thank you.
Yeah,
And yeah, have a nice day, man.
cool. Thank you so much. Really appreciate it.
Bye, guys. This has been very fun. Thank you.
See you, Kotob.
Bye bye.
All right, so I am going to share my Unity screen so that y'all can see it. Okay, let me know as you guys can see it, but I think you can. Should be good. Okay. Cool. Okay, fantastic. Yes, so only Unity. This is what I shared at the moment. So just a quick overview. Generally, let me turn off my camera for better streaming. Okay, cool. So this is what Unity looks like when you first open it. It can look a bit different. The font kind of changes depending on the version you have, etc., etc. And it might change in terms of what you see as scenes, okay? So generally, the most important things that you have inside of Unity are your inspector, your scene, your game, your hierarchy, your project, and your console. So what exactly are each of these? Well, for starters, when you open Unity, or when you open any folder on your desktop, usually you have files and folders. So you can find all of these files and folders inside your project under your assets folder, all right? So currently, masalan, we are in a scene called sample scene, and you can find this inside a scenes folder Unity generates, and there you can find your sample scene, okay? Let's say you wanted to create a script. A script is basically something you write code in. So inside your project, you can right click and create a script. So once you do this, you basically created your file. So I'm going to call this the first file. And this is basically a file that you have inside your folder called assets. Okay, so you can find all of this stuff inside your projects folder. Usually whenever you do something, Unity overreacts and decides to just refresh everything. So this is totally fine. In the console, you can generally see any errors, any problems. You can ignore this for now because we're not going to write any code today unless we have a bit of time. But yeah, generally the console is where you see what is happening in the code. All right. Let's say you wanted to see what this file was about. So you clicked on the file and you see that in the inspector, something opened. So what opens is information about whatever it is you clicked on, right? So you can see here, for example, I have the main camera. So if I click on the main camera, it's going to show me a bunch of other things such as transform, camera, and audio listener. All right. So the point of the inspector is to inspect a certain object that you're looking at. Okay, pretty simple. Does anyone have any questions about the project, the console, or the inspector so far? Well, are we good? Okay, cool. Next we have the hierarchy. So in the hierarchy, this is more or less where you find all of your objects. Okay, we have 4 chat. Cool. All right. So as I decide to write inside my hierarchy, I can create a bunch of things. So let's create a square. So the way to create a square is to go right click, 2D object, sprite, and I'm going to choose a square, for example. Okay, so I'm going to do it one more time. In the hierarchy, I right clicked, 2D object, sprite, and I chose square. Okay, when I did this, I got a square inside my scene. All right. So as soon as I clicked on my square, you can see in the inspector that I have its name, which is square. I have its transform, which has a position of 0, 0, 0, a rotation of 0, 0, 0, and a scale of 1, 1, 1. All right. So generally, the position is where the thing is on the screen. So let's say I change x from 0 to 1. You can see that the square moved to the side. Let's say I put it back at 0. It's going to move back to the center. Okay. The rotation is literally about how it's rotating. Generally, you might want to rotate on the z-axis because you're looking at it from the x and y plane. So the z is the one in the center, and this is the one that spins around itself. Okay. Generally, I don't think you're going to need this very much, depending on the kind of game you're making. But this is what the z-axis does. So the more you push, the more you pull, the more this number changes, and you're going to be able to rotate. And finally, for the scale, the x, the y, and the z. So the z, you're not really going to see much of a difference because you can't really view the z-axis in 2D. But for the y, let's say I set the y to 2. This means that the box is going to grow in size to 2. All right, so now it's a rectangle. It's not really a square anymore. You may have noticed and know when I clicked on the z. So I click and hold on the Z, and I'm able to spin it around as much as I want. You can practically do this for any of these. So let's say I clicked on the X and I moved left or right. It's going to increase or decrease the size of the square that I have. Okay. So generally, just the two ways to change them are to either change the number manually or to click on the X, Y, or Z and to move left and right to change its size. Okay, yeah, geometry dash, very fair. All right, let's take, generally whenever you create a 2D object, let's say it's a square, it's going to give you something called a sprite. So a sprite is basically a picture. So when you guys create your 2D characters, you're going to bring them into Unity, and you're going to make sure to place them inside sprite renderers. So a renderer is something that shows you a thing, and a sprite is an image. Okay, so if I want to change the color of my square, for example, I can click on it and I can change the color from inside here. Okay, this is the color wheel. I can change it to blue, for example. I really like the color blue. So I'm going to go for like a dark blue, something of the sort. It's okay. It's not a bad color. And one thing you can also change is the transparency of the object. All right, so you can make something more or less transparent depending on the A, okay, which is alpha. Generally, if you guys want to have transparency, you have to make sure that your images are in a PNG format, okay, not JPEG, not JPG, because PNG allows for alpha, yani for transparency. All right. Yes, speaking of cubes, we used to have a cube called Bob on the server, and he was basically the start your Blender cube. So if you speak of Bob on the Discord server, there's a chance that you will unlock some memories for some people. Hello, we created our cube and we have our main camera. So this is the first step. All right. Next, we're gonna just quickly go over, well, not quickly. I mean, it depends on how much speed we can go. Okay, so you guys need to tell me whether we're going too fast or too slow. All right. So just to summarize, is inspector, hierarchy, project, and console good? Are we fine with this so far? Yes, perfect. Okay. So one more thing I want to say about these windows is just like when you open a few folders, you can move the folders around. You can do the same thing with each of these. So let's say I wanted to move the console, for example, I can click it and drag it, okay? And when I do this, it's going to pop out and go somewhere else. Okay, so I drag the console to the right of the scene and the game and to the left of the inspector. And then I can do this again and bring it into the console. And if I ever mess up my my screens, I can go into window and then into okay, so I can go into panels actually, and then I can see console, game, hierarchy, inspector, project, and scene. So I can see all of these here in front of me. Okay, does this make sense? So in case you ever need any of these scenes again, you can always find them inside your window panels. All right. And if there's a certain layout you want, you can also go into layouts. You can go 2x3, 4, default, wide, or tall. So let's try the default. Nothing's going to change because this is what it looks like. If we go for the 2x3, for example, it's going to look like this. This is very weird for me. It's not something I'm comfortable with. So I'm going to change it back by going window, layout, and default. Okay, so this is back to the default. This is what it looks like. And the sample scene, when I click on this arrow over here, it's going to show us the main camera and the square. You may see that the main camera looks a bit different than what we're seeing in our scene view. And this is because the main camera is showing us the game view. I can see that we can't really see the square very well. So I'm going to change its color to red. Okay, so I think we can see it now. Okay, any questions? I think it's relatively clear. Close the whole panel on you. Yeah, basically that, Ali. All right. So I'm going to add something called the rigid body, first of all. Okay, so what exactly is a rigid body? Let's think of ghosts. Can anyone here see ghosts, like under normal circumstances? Generally, you can't really see them, but we know that if ghosts existed, we know that they can go through walls, and we know that we can see them, all right? So generally, the square at the moment is a ghost. It can go through everything, and we can see it, all right? So how do we give it a body? We do this by literally giving it something called a rigid body, okay? So let's add the component called the rigid body. And when we do this, what I did is basically I clicked on add component and I typed rigid body. And considering that this is a 2D game, we're going to add the rigid body 2D to it. Okay. Kotob did go quickly over, Kotob did quickly go over the different body types. Generally, you have static for something that doesn't move, but you want to give it a body. Dynamic is for something that does move and is affected by physics. And kinematic is more or less the same thing, but depending on whether you choose dynamic and kinematic, the way that you interact with your items, with your game objects, changes. Okay, so you don't need to worry about this for now. We will get to it when we do get to it. Yeah, but generally all you need to know at the moment is that rigid bodies give your object a body and it allows it to interact with something. All right, so if I click on play at the moment, what's going to happen is the box is going to fall. So if you look into my Y, you can see that the box is falling. Exactly, gravity. And the reason gravity exists is because we have a rigid body. Okay? Let's say I wanted to add another object, and I'm going to go again, right-click to the object sprite, and I'm going to choose square again. Except this square is going to be a bit different. أول شيء, I'm going to set its position to 0 on the x-axis and -2 on the y-axis. And I'm going to scale the y to, sorry, not the y, the x to 4, okay? So I more or less created a platform, okay? So what do you think will happen if I click play right now? Okay, let's try. When I click play right now, yes, exactly. So the second square, which is square 1, it's a ghost. And I'm going to change its name from square 1 by clicking on it and going to the inspector and typing platform, let's say. Platform, okay? What color would you guys like the platform to be? Or is white okay? White is okay. Cool, perfect. I mean, I guess you guys can see it well, so this is great. If we add a rigid body to it, what's going to happen to it? So what will happen if we add it will fall as well. That's very true. So let's add a rigid body to it anyway, because we want it to exist in the world. We don't want it to be a ghost. But do you remember when I said we can set it to static? So let's do that at the moment. All right. When we set it to static and click on play, the platform is static. The box is not. So since it's static, it's not going to fall. If we change it to kinematic, for example, or dynamic would mean it falls. Exactly. Kinematic dalit mahalla, which is fine. It's no biggie. All right. So depending on what kind of thing you give it for the rigid body, it changes. One very important thing to know about Unity, which I just noticed you guys should know. Okay, let's take our platform, okay? Our platform is currently a square and its color is white, and I am currently in play mode. So if I change the color, and then if I make it bigger, and not red, let's go for green, okay? And if I decide to change its rigid body to dynamic, okay? So I did so many different changes right now, right? When I click on play, you're gonna see that it's back to static, the scale is back to 4:1, and the color is back to white. And the reason for this is that when you do changes in Unity in play mode, it's not saved because you're actually playing. So please make sure that whatever changes you make, they need to be in they need to be in not play mode, okay? Because again, if you are in play mode, it's going to be a problem. And the problem is, no, nothing is going to be saved. All right. So let's take these two things for a bit. I'm going to go back into the scene, and you're going to see that it has like these 4 blue dots. All right. So generally, so you see these buttons over here. You may have them at the top, by the way, horizontally or vertically. And you can access each of them by clicking on Q, W, E, R, and T. Okay. So what exactly do these do, and why am I talking about them? Well, basically, when you are creating your game in Unity, most of the work is going to be inside the scene view, all right? Not in the game view. The game view is where you view the game. This is what the players are going to see. But right now we are building a game, so we're going to go into the scene. And these tools are extremely helpful. All right, so the first one is the hand. So what the hand does is it just allows you to move your screen around, all right? Next is this one, the move tool. You can get to the move tool by clicking on W, and it allows you to move your items up, your game object, sorry, up and down and left and right. And there's also this little square. I don't know if you guys can see it very well, but when you click on it, you can basically more or less freely move it in the X and Y directions. All right. So if you want to move in only one axis, you can click on the arrow and move it. And if you want to move in both directions, you click on this square, all right? Next is E, which is the rotate tool. And can anyone guess what the rotate tool does? Sah, that's rotate, wonderful. Okay, you guys are catching on pretty well. That's amazing. All right, next one is the scale tool. So again, can anyone guess what the scale tool does? Let me change its color for a tiny bit. Okay, I think you guys can see the square in the middle a bit better. All right. Yes, y'all are super smart. I love it. So exactly, the scale tool allows you to scale. So if I grab one handle, I can scale it sideways. And if I grab the other handle, I can scale it up and down. And if I grab the white center, I can scale it up in size and down in size proportionally. All right. And then finally, we have the rect tool. And the rect tool is basically a rectangle, and you more or less, you don't usually use this in the scene as much as you do in UI, but it's just a tool that's also there. Is that you see this little dot in the center? This is more or less where the center, this is actually where the center of your game object is going to be, all right? So sometimes you might want to have it at the bottom or on the right or on the left or something of the sort. And the reason you would do this is to have your character, for example, jump or change size or change shape without changing the way that they look at the moment, all right? So this is like a very quick overview on all of these tools. The last tool is the transform tool. You can ignore it because it's like a hybrid of everything else, more or less. So just forget about it. Generally, all you're going to need are the move tool because you're going to move objects around a lot. The rotate tool, you won't need it much, and the scale tool. All right, so it's practically the move tool, the scale tool, and the view tool. All right. And obviously, you can also go in and out of Unity by scrolling in and out. All right? Cool. Any questions so far? Cool, perfect. Okay. Again, please let me know if I'm going too fast or if there's anything that you guys would like. Yeah, because again, I want you guys to understand everything that you're going to see in Unity so you can make the best games ever. All right. So Next, we talked also about colliders. So what is a collider? We talked about rigid bodies, which gives your ghost a body. But why can a ghost pass through things? Generally, it's because they can't collide with them. صح? So let's add a collider to our objects. All right? So how do we do this? Can anyone in the chat remind me how to add things onto our objects? Exactly, add components. Well done, Ali. Also, Ali, you asked a question, and I'm going to answer it right now. And you asked whether if we create a ball and give it a put an angle to the platform that's under it, if it would roll. And the answer is yes, after we add the collider. Okay, I was just very excited to answer the question, which is why I did it right now. So, مثل ما أنت قلتوا, exactly. So we're going to add a collider. And what kind of colliders are we going to add? They need to be a 2D type of collider, all right? And the reason for this is we are in a 2D component. The reason I'm stressing so much on this is because I've wasted hours of my time before on accidentally adding a collider that was not a 2D collider, and you know, just like bashing my head across things. And I talked to the senior developer, like, why isn't this working? And he was like, what kind of collider do you have? And it was a very awkward conversation, to be honest, because I was like a year and a half into my, you know, working on this. So yeah. Anyway, so we add the box collider 2D, and we know that we added the box collider because we have like a very faint green outline around it. Now, to actually see it better, you can click on the edit collider, which allows you to see like the small squares, and you can pull these around to give your object more space. Okay, so technically the collider is going to exist around whatever space you want it to be. So masalan, let's say I don't want my collider to be on the square. I want it to be outside of the square. I'm going to change the offset to 1, for example, okay, or to 2. So if I do this, yes, this collider is for the square, but it's outside of the square. So in summary, a collider does not need to be around an object. A collider is basically just a tool that you use to see whether you hit something or not. All right. So this is a bit advanced, so hold on to your socks, but I'm just going to explain this in as simple way as possible. How many of you have tried to jump? Okay, how many of you have played any platforming game? I think most of us have played platforming games, all right? One of the coolest things about platforming games is the double jump, right? I really, really like double jumping in games, and I love to see how everyone explains it. You know, some people are just like, press space twice to double jump. Others are like, here's a jetpack that you can use when you double jump. Others are like, you can use your wings to double jump or something of the sort. So depending on which game you're using, each one defines a double jump differently. But why is it that a double jump always happens after you land on the floor? Why can't you double jump, for example, by hitting the ceiling? You know, maybe your head hits the ceiling and then you can double jump again and again. Well, there are a few reasons for this. The first reason is there is always a collider at your feet that checks that you touched the ground so that you can double jump again. All right. So what I'm going to do, just to explain my point, is I'm going to create a new object, and it's going to be another square. So create a square, and I'm going to call this square bottom space collider. Okay. And then I'm going to add a box collider to it because it is a box. And I'm going to make the square, let's say 0.2. Okay. So it's a pretty small square. All right. And if I put the square over here, okay, this square has a collider. صح? So whenever, let's say that this collider is part of the square. How do we do this? We literally do this by grabbing the collider and putting it onto the square. So what I did is I clicked and I dragged. So now the bottom collider and the square are one. Okay, they've basically fused together. I can write a piece of code and I can do some magic and say that whenever the bottom collider is touching something that is not the square, then you're going to see if you can double jump. And if you can double jump, then double jump. Okay. This was a bit of a convoluted example, but my point is that colliders aren't exclusively used for to check to just collide with things. Sometimes you need them outside of the character to do some other extra magic. All right? Does this kind of make sense, or did I just confuse everyone a bit more? Okay, cool. Thank you, guys. All right. How do you change the common parameters for physics? Okay, so Ahmad also asked me a question about physics. This is a bit advanced, so I will answer it later if we have a bit of time and if you would like. But for now, let's just focus on making sure that our square does not fall through the platform. All right? So our platform is currently missing something. What is it missing? It currently has a sprite renderer and a rigid body. So it's missing one more thing. صح, well done you guys. It's exactly missing a collider. So let's add another box collider 2D because it is even though it's a rectangle, we still need the box collider. I know it's weird, but that's okay. So what we're gonna do is we're going to add a collider, and because this is green, you can't really see the collider, but if I click on edit collider, you can see the squares, the light green squares that are on it that say that, hey, this is the collider over here, okay? Hello. Oh, okay. So actually, I can answer your question, Ahmad, with relative ease. So you can change some physics parameters over here from inside your rigid body. So you can say, masalan, the rigid body has a mass of 1. Its drag, if you want to have like linear and angular drag for like air and stuff, you can have this. You can change it from there, and you can also change the gravity scale depending on what you want it to be. So in an example of this, once when I was in a game jam, I created a game where you jumped around, but the jump either felt like you were floating up and floating down, or you jumped a bit too high. So what I did is I increased the jump speed and I increased the gravity scale. So yes, you jumped just as high, but you also jumped very quickly and fell back down very quickly. For this solved my problem. So if you want to add quote unquote weight, you can either do it through mass or through gravity scale. This is just an example. I hope this kind of answers your question, Ahmad. Was it Ahmad that asked? I think so. Okay, fantastic. All right. Another question about colliders was, we'd use colliders if we wanted to replicate Pong, for example. Absolutely, Hadi, exactly. So generally, you have a ball that is colliding with either your racket or your enemy's racket. So depending on what you do, you're going to get a different, when you hit the thing, this is how it works, because it's colliding with something. Collider, can it be used for armor too? Yes, you can use your collider for armor. Would we make the collider outside the player true? Yes. Generally, I wouldn't really use, I mean, you're right. The short answer is you're right. But the way I would do it is I would add a collider for a shield, for example. Okay, and then the shield would be the one taking the damage, whereas the armor would be a part of the player. And I would change how much damage he takes from the design perspective, not from the code perspective. I'll explain this in more depth later if you'd like. Oh, okay, perfect. As long as it makes sense. Wonderful. All right. So let's play and see what happens right now. So I'm actually not very sure if this works. So we may have to debug together because I can't remember if we need the body to be dynamic or kinematic for it to interact with the collider at the bottom. Fuad, you can help me with this? ما بزعل صراحة. Oh, fantastic. Okay, wonderful. This is great. So our square fell down and it hit the platform. All right. So this basically means that our ghosts are now alive. We've basically Pinocchioed our boxes into becoming real squares, which is amazing. So this basically summarizes game objects, our different windows in Unity, rigid bodies, and colliders. All right. If we don't have any questions about these, I will answer your questions. And I think we can take a 10-minute break, and then we can get back to it if you'd like. What I'm just going to explain after that is a basic introduction on code. You don't want a break. I can do this in around 5 minutes, and then we can call it a day. What do you guys prefer? Let me know. Okay, go for it now. 10-minute break, no break. Adam, are you okay with us with us like doing it relatively quickly? Okay, thank you. So I'll answer the questions, and then we'll look into the code. How can we import characters into Unity? This is actually the easiest thing ever. You simply click and drag your characters into Unity. You just grab them from whichever folder you have, and you put them into your assets folder or into whatever folder you want. Usually the way I like to do it is I like to right click and create a folder, and I usually call this folder sprites. Okay, and inside the sprites folder, I click whichever image I want and I drag it in. And then this is how I import my characters. All right. Can you make a collider smaller to test two objects falling on it, one above the collider area and one not? Yeah, absolutely. Let's do this right now. So I'm going to stop the game for now. I'm going to pull the square a bit up. So I'm going to raise it from 0 to 2. Okay. And I'm going to grab its collider. All right. And I'm going to increase the collider size from the bottom. All right. So what do you think is going to happen right now if we click play? Okay, I'll give you guys like 3 seconds to write out your answer. Okay. So I clicked on play. And as you can see, when I click on play, it automatically moves me from the scene view into the game view. And you can see that I am now above, I'm practically floating. What the truth is, I'm not actually floating. What's happening in the scene view is my collider is actually hitting correctly. So let's say I made the collider smaller, okay, then you can see that, yes, I am hitting the green rectangle, but I'm stopping at wherever the collider is, okay? Does this make sense now? Yeah, transparent imposter cube, I love it. Fantastic. Yes, okay, great. So I hope this kind of like answers your both of your questions. I'm gonna stop sharing my screen for a second, just so that, actually before I do. So what I'm gonna do is I'm gonna double click on first file. I'm gonna stop sharing my screen so that you can see the codes. No, I realized that I've only shared my Unity screen. All right, so new share actually. Can I do this directly? Okay, you guys may see a ton of my stuff, but I think that's fine. Trust you guys. And then I'm gonna click on first file. So I'm gonna double click on this, all right? So I'm gonna ask the question, which is, can you change the collider across platformers? What do you mean by this? Because generally you can just change it whenever you want. There's nothing stopping you from changing your collider, and it's actually encouraged to a certain extent. Because you actually want to create something that you yourself made. To do this, you're gonna change your colliders to fit your need. So yes, is the short answer. But if there's anything more specific, please let me know. No, I don't know if I answered your question at all. But yeah, you can change the collider, Akid. Okay, so what we're looking at over here is what a generic start file for Unity looks like, okay? You have these things at the top called systems collections, you have something called the Unity engine, you have a public class, we have all of these stuff. What exactly are they? So in general, the thing at the top, the usings, they are basically dictionaries. You can call them dictionaries for anyone that's just as a basic definition. So generally, if you want to learn how to speak a language, you're gonna have to learn it, okay? And to learn it, you're gonna have to read words, all right? So you're gonna go into different libraries, thank you for the word actually, and you're gonna start learning as much as you can. As if you don't go into a library, then you're gonna miss some knowledge, all right? So if you go into the systems collection library, you're gonna learn things about the systems collections. If you're gonna go into the Unity engine library, you're gonna learn about the Unity engine. So this is basically what the things at the top are, all right? And then we have something called public class first file mono behavior. What are these? So remember when we named the file? We named ours first file. And apparently I wrote the I as a capital letter, which is fine. Because I decided to name this file first file. And this is why this class, which is what this piece of code is called first file, all right? Mono behavior is something that comes with Unity generally. So if you want this script on an object, then you're gonna need to have the mono behavior. All of this is something written by Unity for Unity, so don't worry about it at all. And public is basically about whether the thing can be accessed by other people or not. Okay. So masalan, let's say you have your house and you want to let people into your house. Then you can do a few things. The first one is giving people your key. The second one is just keeping your house open for anyone to just walk in. You know, usually you have this in public gardens, you have this on the street, you have this in shops and stuff. So these are like public spaces. So classes being public are more or less the same thing. Sometimes for parties you need to pay to get in. So this is a different story. But the idea is, when you have a public thing, this means it can be accessed by other people. All right. So here, for example, void start and void update do not start with public, which means that they cannot be accessed by things outside. All right. Very simple, nothing very important. Do you guys remember when we were clicking on play every time we opened Unity? So when we were doing this, what was happening is the game was starting. صح? So when the game starts, what function do you think is called? The start or the update? The game is starting. صح, exactly. So generally, when you start, the start is called. All right. So if you have anything that you want to do at the beginning, you do it in the start. If there's anything that you want to do while the game is running, then you look at update. Exactly that. Kotob also talked about on enable, on disable, fixed update, all that stuff. So I'm gonna go back into Unity for a second. All right, the game is still running. I'm in my scene view and I just clicked on the square. All right. So if I turn my square off over here, this check over here that you can see next to its name will turn an object on and off. Okay. And you can see from the hierarchy that when I click on the square and I click on the off button, you can see that it goes gray. Okay. And this means that it's off. So whenever I turn this on and off, what's happening is I'm actually enabling it and disabling it. All right. So practically all you need to know about enabling and disabling is when an object turns on and off while the game is running, if there's anything that you ever need to do, you generally at this stage don't need this. If there's anything that you need to do, the on enable and on disable are what you'll need to call. Okay. So an example of using this would be, let's say that you have a guard and the guard is looking for you with a flashlight. All right. And every time the guard turns on the flashlight, if you are standing in this area, you are caught. And when the guard turns off, turns off the flashlight and you are in this area, you don't get caught because the flashlight is off. So let's say you had a function called catch player. And what this does is it catches the player. So whenever you turn the light on, you enable this catch player. And whenever you turn the light off, you disable this catch player. Okay, so this is practically where enabling and disabling the catch player comes in. Whereas in the start, whenever you start the game, and whenever the light is first turned on, start is called and then khalas. This is it. It's never called again. Okay. So do we get the difference between enable, disable, and start? I think it should be relatively clear. So كمان مثلا, if we want to write, so the way to do this is to click on, is to write, sorry, blah, blah, blah. So as I write, okay, at this point it's not working, which is fine because I think my Unity did not load, so no, it's okay. So usually on enable looks like this, okay? Void on enable looks something like this. And on disable looks the same, except it says on disable instead of enable. Same thing with update. So the difference between update and fixed update, just as a basic understanding as well, an update runs on every frame, and this depends on how quick your computer is. How many of you enjoy playing games at 60 FPS, and how many of you enjoy playing games at 10 FPS? I think most of us really enjoy 60 FPS. But let's say that our game was let's say our computers weren't as strong as our friends' computers, okay? Richie McRich, masalan, has Habib al-Ghali has a very, very, very high-end computer. And, he has like an RTX 5090 and, all the RGB lights. He also has like ultraviolet and like infrared in the lights because he can see the spectrum and whatever. And his computer can run the game at 1000 FPS, okay? Oh, there is a 5090, damn it. 100,090, I don't know. So if he can run his game at 100,000 FPS and you decided to run your enemies in the game that you made on the update function, then the speed that the enemies are going to move at are going to be at 100,000 FPS. Like they're going to move 100,000 times per second because you said move them inside the update function. So if you do this, it's going to be a problem. So to make sure that the game runs the same on everyone's computers, you usually go for this kind of stuff inside the fixed update. So just to summarize all of this, if you have a character that is moving 1 pixel every loop, all right? If you're gonna put this in the update, then on one computer, in 1 second, the character can move 60 pixels, and on another computer, they might move 100, and in another computer, they might move 20. So this is why you would put the move function inside the fixed update, because this way, the fixed update runs every 60 frames. So this means that no matter your computer's strength, it will always run the same on all computers. This is why if you've heard of games like Elden Ring or Dark Souls being capped at 60 FPS, this is why they do this, so that the characters don't move around in a very wacky way. Okay, fixed update, if I'm not mistaken, it's 60. All right. And they also have like magic internally to make sure, and if your game can't run at 60, this is what it will look like if it was moving at 60. All right. So yeah. Also, most of the code that Kotob wrote today, don't worry about it. We're going to get to it later on. This was just to show you the basics of what they're like. All right. Yes, exactly, Hadi. The point of fixed update is to keep the game stable between different spec computers, so that no matter where I'm running the game, it'll be the same. One of my favorite examples of this is Binding of Isaac. I don't know who has heard of it or has played it, but it's a game about a crying baby that is running around inside the dungeon, inside like his in his basement, and then he has to fight himself or Satan or something of the sort later on. But anyway, in the original version, it gets really, really fast if you try to run it on your computer today, because your computer can run the game really fast. So generally the game moves fast because they more or less like in the engine that they used, it was kind of like running in the update function instead of in the fixed update. This is just like a high level example of what it's like. Okay. I want to see if there's anything else that you guys mentioned. Pause, resume, are they also related to enable and disable? That's actually a pretty good place to use them. So yes, you can use this. Generally, from my experience, the way I usually use pause is by stopping time. So there is a function for time in games. If it's at a 1, this means it's moving at normal time. If it's at a 0, then time is stopped. So this is kind of how people use it in games when they want to like speed up the game or speed down the enemies or whatever. They use Hikshi, all right? So you can use it on enable and on disable, but not necessarily. Okay. Are there any other questions that I missed? Okay, let me just check the thing that Kotob shared with you guys to see if there's anything I missed. Okay, so there is one thing I missed, but I think that's okay, which was reading inputs. We can leave this for next time. But generally, to move your player left and right, you're going to be using your rigid body, because again, to move, you're going to need to have a body, and you're going to move left and right. But we'll leave this for later because it's 8 at the moment, and I think you guys are tired. So if we have any other questions about Unity in general, not about code, just about Unity and how it runs and whether you have it downloaded, etc., please let me know. And if not, then we can hop onto Discord and chat some more, or just sleep or have dinner or whatever. Do you recommend us to experiment with these controls today or wait for the next session? Fuad, are you still around? What do you think? And I think you can definitely play around with Unity and like try to create your own objects and give them. So I think Hadi, no, it wasn't you, but someone did ask, for example, if you have a platform and you rotate it and you have a ball, whether it rolls down or not. So these are things that I encourage you to try just to see how Unity works and to get a feel for the entirety of it. Okay. And any questions you have, especially if you'd like to jump and advance and stuff, you can always do so and ask us on Discord about how to do things. If you have any other questions as well, we have our sessions from the last year from GA2, and you can watch it in both English and Arabic. This way exists. Mohamad asked if I can explain on enable and disable again. Yeah, for sure. So let's say, I'm going to try to give you another example to try to explain this. Let's say you have a, let's say you have, okay, you have a guy and he is dealing cards to you, okay? Every time he closes his eyes, you can steal a card from him. Every time he opens his eyes and he catches you stealing a card, then he is going to punish you for it by taking all your money and throwing you in jail. Okay? As a developer, I want to make sure that every time his eyes are open, I want this function of catch player to be called and for the player to be put in prison. So to do this, I create a script that I put on his eyes, okay? So what this means is I create, for example, square now has the word eyes. So this is an eye. I know it looks nothing like an eye, but that's okay. And I put the script on first eye, okay? Yes, exactly. So depending on the state of his eyes, if the eyes are off, actually this is wrong. You shouldn't put first file over here. First file should be on a different object. But no, the idea. If the eyes are off, I want the script not to run. If the eyes are on, I want the script to run. Okay? So when it's enabled, run the script. When it's disabled, don't run the script. The reason we put it in on enable and on disable is to save on processing power to a certain extent. If I put it in update, then this script is always going to run as long as, the function is always going to be checked as long as the script is on. Okay, if I put it in start, then it's only going to run the first time, that's it. So when I put it in on enable and on disable, it will run when the object is enabled and it will not run when it is disabled. I do believe that on enable and on disable are a bit not excessive, but they are a bit advanced, and you will most likely not use them during our sessions. But this is more or less it. At work, for example, I really like to use on enable and on disable whenever I have certain objects that call the internet. So whenever I create a multiplayer game, I don't want to keep calling the server. Now that becomes very expensive on the user because they're going to be calling, like they're going to imagine sending like 100,000 WhatsApp messages and like every time you open WhatsApp. It's very expensive for you to send these messages, and it's very expensive for the server to get all of these messages. So I use on enable and on disable whenever I need to call a certain function in a multiplayer game. So it's a relatively advanced thing that you won't need to use at the moment. But did the first example I give kind of make sense? If not, I'll try one more time or ask someone else. I will استعين بصديق basically. Okay, great. All right, طيب. I think we should be good to go then. If anyone has any questions, if you have any feedback, if there's anything that you'd like for us to do for next time, please let me know. And if not, then I wish you the best of nights, and we'll talk soon. Cool. See y'all. I'll probably upload this by tomorrow. So see the recording tomorrow, then that was yesterday. See ya.